Okay, today we're doing 8.7 exponential and logarithmic equations. So we're not really learning anything new specifically, no new properties or anything like that. We are learning how to use them in different ways. Okay. First, we're going to convert from logarithmic notation into exponential notation. We're doing this because we're going to have to use this in solving equations. This is a very important property or definition to be used. So we're going from log to exponential. Okay, so remember our little rhyme. The base to the outie equals the any. There we go. We use our little rhyme and we're good. Now we're going the other way. So the base this time is the 2. So the base, so that means it's log base 2 to the outie. So 8 is what this is equal to, equals the any. Well, that's equal to, and that's the any. So the any is inside the logarithm. All right, now we're going to review evaluating. So what we're going to do is rewrite this logarithm as, first off, it's log base 3 of 9 squared. I brought the 2 up, plus log base 3 of 3 cubed. Okay, 9 is 3 squared. So this becomes log base 3 of 3 squared squared, so that's 3 to the 4th. Plus, well, log base 3 of 3 to the anything is that thing. So log base 3 of 3 to the 3 is 3. Said 3 too many times. Well, now here on that first one, I have log base 3 of 3 to the 4th. So log base 3 of 3 to the anything, 4 in this case, is that number. So I have 4 plus 3, which is indeed 7. Okay. Log base 3 of 6. 2 times log base 3 of 6. I'm going to bring the 2 up. So it's now log base 3 of 6 squared minus log base 3 of 4. Minus means division. So this becomes log base 3 of 36 over 4. Well, 36 over 4 is 9. So log base 3 of 9 is log base 3 of 3 squared. So that's squared, that's my answer. Okay, there we go. Oh dear. How can an equation such as 3 to the x equals 32 be solved when it is difficult to express both sides as a power of the same base? Okay, so right, this is 2 to the 5. I can't express it as a 3. Converting the equation to logarithmic form, right? The base, there we go. The base, I'm not in. It's going to let me erase it? Yes, okay. Better. All right. The base, there we go. So x equals the base to the outie. So my x is my outie, which means that's what it's equal to, is equal to the any. That's the 32, so that's my any. Provides an exact answer, but it is difficult to find a decimal approximation for this number. Okay, so we use what's called the change of base formula. This is so you can put it into your calculators. Okay, so the point of this change of base formula is, notice I have A, B. All right, the thing I've always said, the little rhyme I use is the like on a submarine, right? A submarine is underwater, so the sub stays under. Okay, the sub is the base. It's the subscript. It's the thing that's down below. That's the subscript. So it stays down. So the sub, which is B, goes down here. And notice that it's a completely different base on the logarithm. You can choose it, does not matter, this will always work. So what we automatically do is choose a version we know, like log. Our calculators can do a log, so we just use log. Okay, so what we do is, this is from the previous example, 3 to the x equals 32. We rewrite it as log base 3 of 32. Sorry, we use the change of base formula, and it's log of 32 over the log of the 3. Now, log is something we can plug in our calculator. We can plug this into our calculator. Log 32 divided log 3, and out comes our lovely answer of 3.1547. Okay. So, another way to do this, okay, is here we are taking the log of both sides. Let's see if I can write this out for you. Okay, so we have 3 to the x equals 30, oops. And what we do is we take log of both sides. Now we know we can do this because if I gave you this equation, you would immediately say, oh, 3 to the x is equal to 32, because I know if I'm matching log and log bases, I said what's inside equal. So you can see right off I can do this. So I can take the log of both sides. Well, I'm going to then take the x down as an exponent, right? So this x goes to the front as the exponent. Then I subtract it I divide both sides by log 3. So you can see I divide both sides by log 3. They cross out here, and I get log 32 over log 3. Plug it in my calculator, and again, I get my lovely, I wasn't in highlight mode. There we go. 3.1547. All right, moving on. 4 to the x plus 5 equals 12. Well, again, we can't solve this we can't make 12 equal 4 to the anything or 2 to the anything. So we're going to have to use this other form. We take the log of both sides. Okay. We use the exponential rule so that this x plus 5 can come down in front. Now I'm going to divide both sides by the log 4. Okay. And now I subtract 5 from both sides. And that gives me the negative 5 there, the minus 5 there. Plug this all in my calculator. Log 12 divided by log 4, and then minus 5. And I get my fabulous answer of negative 3.2075. Okay. Now, this one I fleshed out a little bit for you because this is a tough concept. Okay, example 3. Carbon-14 has a half-life of about 5,730. So in our formula over here, this is half-life. That's why you can see that down once I plug in the numbers, I've got 5730 there. Okay, a piece of wood contains 19 grams of carbon-14. Well, this is our current amount of element. Okay, so that's A, and there's my 19. Predict when there will be 18 grams. So this is now my future amount of the element. And so I plug in my 18 right here. Okay, and since we're talking half-life, that's why there's a 1/2 in the middle. Okay? All right, so this is the formula we will always use for half-life. Write it on your formula sheet. Go back one more slide. They will always give you basically this half-life amount. So you don't have to worry about it. What it is for carbon-14, what it is for whatever element they're going to be tracking. Okay, so now we've written the formula. Here's the equation for us. That's the equation from the previous slide. Now we have to solve it. We have to solve for, our lovely answer is this T right here. All right, so the first thing I'm going to do is get this 19 stripped off. So I divide by 19. And that gives me the next equation. Well, now I have that T is in the exponent, so I've got to get it out of the exponent. The only way to do that is to take a log of both sides. So I'm going to take just the standard common log of both sides. And that's what we have as our third equation. But now I'm going to be able to take this whole, sorry about that, I did it again. There we go. This whole exponent and bring it down to the front, which you can see is right here. All right, so now I'm going to divide off that log 1/2. See, there's the log 1/2. I'm dividing it up to the other side, and I get it there. And I have T over 5730. Multiply both sides by 5730. And I'm left with T all by itself. So I plug all of this into my calculator, and I get approximately 447 years to get down to 18 grams. Okay, so that's half-life. You may need to go over this again when you do your homework, because you'll have some half-life problems. Let me go back to that and say something. They will always give you... Okay, so example 4. Solve log base 27 of x and set it, and that is equal to 2/3. Okay, so what is this saying? This is saying, here we go, the base to the outie is equal to the innie. So I've just gotten the x out of the logarithm. X is equal to 27 over 2/3. Well, I know that the cubed root of 27 is 3. So that gives me the 3. And then I square that. And I get my 9. Answer done. That's simple. Okay, our next one, log base 9 of 6 plus log base 9 of x is equal to 3/2. Well, we're going to combine these together so that this plus becomes a multiplication. So that's how we got the 6x there. Okay, so now we're going to rewrite this using our definition. The base to the outie is equal my innie. There we go. Now I can solve for x. All right, I'm going to divide, okay, I'm going to simplify the 9 to the 3/2. Square root of 9, that gives me the square root, that's 3. And then I have to take the 3 and cube it. Sorry, that's 3. Now I take the 3 and I cube it, and I get the 27. I get 27. Well, that's equal to the 6x. So I have to divide off the 6 to get x. So now I have x is equal to 27 over 6. They both have a 3. We simplify it. We have 9 halves. Now, we're going to check this. And if I put this into my original equation, which is this one right here, we're going to see if that is equal to 32. Oh, sorry, 3 over 2. So, log base 9 of 6 plus log base 9 of x, which is 9 halves. All right, because of the plus, we're going to condense this together. Okay, and that gives us 6 times 9 halves. Well, the 6 and the half give me 3. So I have 3 times 9, which is 27. Right? So the 2 and the 6 turn this into a 3. And then the 3 times the 9 gives me 27. And we need to know if that is 3 halves. And sure enough, it is. Well, I think the next slide is going to go into... Okay, so the sub base to the outie equals the innie, right? So I'm going to show you why this works. Okay, the base to the outie, 9 to the 3 halves is equal to 27. Well, square root of 9 is 3. 3 cubed is 27. Remember, we came up with that over here. Okay, and we're done. So that is a good, and it does work. So it's a good solution further. No. Okay, example 5. Solve log x equals 5.37. So what is x? Well, remember log is log base 10. Sorry, I didn't finish this. The 0 is terrible. Log base 10. So that means 10 to the outie is equal to the innie. So 10 to the 5.37 is equal to x. I plug that in my calculator. I get 234,423. For b, we have to solve 2 log x plus log 4 is equal to 2.5. So what's x? Well, we condense this all together and we get log of 4x squared. 4x squared is equal to 2.5. Again, we use our equation and we get 10 to the 2.5 base to the outie is equal to the 4x squared, the innie. All right, we do 10 to the 2.5. 10 to the 2.5 gives us 16.288. We divide by 4. We get 7906. We square root that. We get plus or minus 8.86. But we started with the log x, can never be not negative, so my answer has to be the ever so lovely 8.89. 300. Okay, and there's your homework. Have fun.